So good morning, everyone. So I'm the last one before the lunch, so I try to keep it short. Yes, we will talk once again about Edge AI, and then I will present you a new platform that is called Edge, that is hosted by the Eclipse Foundation. And it's a work that is supported by two major initiatives in France and Europe, called Deep Green and NeuroKit 2E. And actually, I'm Pierre Gaillard, and I'm the coordinator of the Deep Green project. Okay. So how to, no? It's not working, actually. Okay. Edge AI marks a major transformation in the way of doing AI. The idea is to process the data directly as close as possible to the sensor, sometimes directly into the sensors, in order to enable real-time processing. It's also a way to better protect your data and your model. It allows offline operation when you don't have cloud access. And it's also a way to reduce cost by reducing the energy consumption and the infrastructure needed to perform your AI inference. Clearly, there are more and more applications, and this way of doing is more and more find more and more its way in our daily life. You can think about your smartphone for sure, but also in your vehicle. Even if many applications, if you think it's local, actually it's not. So many of your data is still sent to the cloud. But still, there will be more and more application at the edge. And for sure, it will be also the case in the vehicle. So you can think about autonomous driving and driving assistance. You can think about predictive maintenance, but also you can think about how to interact with the vehicle system, or to improve the driver monitoring and safety inside the vehicle. And actually, it would be also feasible to do all this AI workload inside the vehicle, because there is a huge transformation in the vehicle. The first one is electronic architecture that is going to be centralized and zonal. So we will be able to share resources, and that would be a great to perform AI workload, because also this hardware architecture is becoming more suitable for AI based on chiplet, meaning that we will have access to AI accelerators to perform AI, and there are also software and hardware design that is now feasible, and we will think that about in a global co-design. So it means that we will be able to think about the AI in terms of software, but also hardware. Unfortunately, there are still a lot of limitations today to do Edge AI. So basically, we have a very fragmented ecosystem and solution to do that. So at one side we have the deep learning frameworks that is well known to do AI, and they have some extension to do Edge AI. But actually, so there are runtime. I mean, you will need some runtime to do that. You have limited interoperability actually with such framework, and at the end, you don't have actually open source code. No, what it's running, it's a closed source execution. You have also optimization compiler, but it's very low-level approach and extremely complex pipeline. So if you are not expert, it's quite difficult to use. And you have also hardware-specific SDK that are provided by the hardware vendors, but mainly it's their software. It's closed source. It's sometimes even black box, and so. For sure, they do not encourage the portability between several hardware platforms. So at the end, we have pragmatic solution, and it's hard to bring some innovation, and you will lose a lot of time and a lot of money when you want to, for example, to change your hardware, or if you want to test another software to optimize your hardware, to optimize your AI, and so on. So it's actually it's still complicated, and that's why we believe that we need we still have some needs for Edge AI. The first one is we need to streamline the workflow and to ensure smooth interoperability across tools and tool chain, but also up to the hardware, because the hardware needs to be heterogeneous, and we need to find solution for that. We also need to masterize the deployment, because if we don't master the software part, at the end we will have a dependence also on the hardware side. And actually, if we want to integrate sovereign technologies, European technologies, in terms of hardware as well, because Europe is spending a lot of money with the Chip Act to develop new architecture, chiplet architecture, advanced memory, and if we want to make sure we can integrate all these beautiful technologies, we also need to control the software part. And at the end, we also, because Edge AI is often related to critical and safety environment, we need to find solution, software solution for these needs. And actually, there's no real solution right now. No platform is dedicated to bring solution for that part. So we need to accelerate compliance with with industry standards and all these frameworks that are coming. And I think also about the AI Act for that. So basically, we are working on the first collaborative and open source platform dedicated to Edge AI. The goal is to go beyond fragmentation and go beyond black box by providing an end-to-end integrated framework and platform that goes from design, so you can design your own deep neural network, and then optimized regarding the edge constraints, and you will be able to generate a source code that can be deployed on your hardware. The idea is to have an open and modular platform with very minimal dependencies, and the goal is to have a collaborative environment where you can pick the functionality you need, and you are. Well, we have a strong interoperability with a lot of standards, and the goal is to be able to, if you want to only to use the optimization part, you can use the optimization and just leave the platform. But if you are interested by the code generation, you can also use it. I mean, pick the functionality you need and leave the platform if you think there are better options everywhere. So the idea is to have a complete platform, so the design, the optimization, and the deployment, and to foster trust when doing that. So the design, So you, as I said, you can design your deep neural network, so convolutional network, recurrent neural network, and so on. The most standard neural network we are using for vision and time series processing. And here is a simple example what we want to do when we do Edge AI. So basically, it's to because every operation is critical when you are doing Edge. So we want to, for example, do fusion of operation in your model. It's actually a very simple example of what you could do. So you want to match and fuse two operations in your neural network. Here it's what we call convolution and batch norm, and actually this can be expressed as a single convolution. So I won't go into details, but yes, you can do that with other frameworks. You can do that with what is called ONNX, which is a standard to share and to save AI model, a deep neural network, but it's quite complex. You can do that also with ONNX script, which is another tool provided by Microsoft, but it's still quite complicated. You can do also with PyTorch as well, but again, you have to go deep in the code to do that. And this is what we offer with Aidge. It's to do that simply as you speak, as you would do a request. And actually, because we have a good representation of your model, you can do that simply, and you can express as a graph matching system. In a graph matching system, you can search, for example, a convolution followed by a batch norm, and then fuse and replace this operation by another convolution. So the idea is to have a simple manipulation on your graph, and also to be able to understand what you are doing, understand the complexity of your model, and understand what the transformation you are applying will be. So we have a lot of tools for that, and you can actually dive into your model also with interactive tools. The idea, once you have designed your model, is to optimize your model. And as I said, what you usually want to do is to simplify your model that is represented as a graph. And actually, when you are using PyTorch or Keras, but you can have sometimes the same model but expressed differently. So this is, for example, a layer norm operation that is expressed by PyTorch or Keras. It's exactly the same operation, but the atomic operations are not done in the same order. And actually, you want to transform this operation into a standard operation called the layer normalization that is supported, for example, by ONNX. And to do that, so we can use our graph matching system and express in PyTorch or in Keras. So here is an example with PyTorch, and then automatically transform this complex graph that is given by PyTorch to a simplest one expressed by Aidge. And so this is one example of transformation you can do, but actually we offer several what we call recipes. It's automatic transformation of your graphs that will enable fastest inference. And actually, yeah, so we provide several graph transformations that can be automatically applied to your model. We have also other kind of optimization, such as what we call quantization or compression. Quantization is the way to convert your parameters to lower precision data types. For example, so you can convert your parameters from a floating point 32 to int 8. Our compression is the fact to decompose some layers such as convolution into smaller operation, and you can do that also automatically with Edge. And actually, so we do that without knowing the hardware, so it's hardware agnostic, and then you can use both methods and you can combine both methods to have a really breakthrough performance. And actually, we are outperforming some very well-known framework. So outperforming, for example, the Emmet from Qualcomm. And we can achieve very good accuracy, but with a very good model compression and achieve very fast inference on the target. The deployment, once you have optimized your model, you want to deploy your model. So for that, we have two ways, basically. So one is to export the model into an NX, which is a standard format that can be ingested by a lot of SDK. But our goal is also to control the deployment. So we can generate a source code that can be then compiled and deployed on your hardware target. So we have a code engine that automatically generates high quality standalone source code. We have what we call reference C++ export that is quite generic and can be deployed onto mainly almost all the hardware targets that can ingest C++ code. But we have also some specialization for dedicated hardware. Basically, we use as a third-party libraries that are open source and that can improve the inference time for some hardware. So here is a landscape, let's say, of the hardware targets we currently support. So basically, a lot of ARM targets, hardware targets, RISC-V targets, and then it's built by a lot of companies, and I would like to thank them to be involved in this development of supporting such variety of hardware targets. So just so we did some benchmarking, and actually it shows that we are at the level of many other platforms. So, for example, we have a comparable result compared to an NX runtime. But we have also similar results compared to some vendor solutions such as QBI provided by ST or almost similar to TensorFlow Lite. The idea for us is also to provide trust when developing AI. So clearly, yes, we have an open source code. So when you develop, all the methods are open, but also the source code we generate and that can be deployed on your hardware is also open. So meaning you can audit and you can verify all the code. We are also working with some other projects, such as the Trustworthy AI Foundation, to bring some trustworthy element inside the platform. So, for example, we have some learning algorithm that help to improve the robustness and the resilience of the model inside for its inference. We can also, for example, test the neural network under hardware fault tolerance. So, for example, what happens in your neural network inference if you have one bit flip, for example? Is it still the same result or not? And we are also working with ONNX to create a new or an extension of the format to make sure that the standard can be also used for certification, because actually this format, when it has been developed, has not in mind these certification needs, and now we need to clarify, verify, complete this format. And the idea of this working group is to provide informal and formal specification for all the operation in a neural network. Also to find a way to have a traceability between the informal and formal specification, but also, thanks to Aidge, to have a reference implementation of all the operation, and also to have a reference implementation of the neural network. That is not to be, the intention is not to be performant, but to have a reference optimization that we know that is certifiable. And actually, we are also working with other partners to see how the framework can be used to meet aeronautic certification, because for now existing ML are not compliant with that, and so we work to make sure that we have a semantic preservation of the model, meaning that we are checking that we have the same behavior on the hardware targets and on the training environment, meaning on your computer. That we have, as I said, a traceability between the model description and the C code that is that will be executed in the target. Make sure we can have a predictability of the time, and so actually we have already some result on that, and we have a plugin actually and we have already a plugin in Aidge that is called Aceton, that makes sure that, for example, the semantic preservation is correct, that we can verify the time predictability, and so on. And the idea at the end, so it's to mix everything into a benchmarking solution, making sure that, for example, we have the safety or NNX reference that can be compared to some very performant implementation on the hardware. And the idea of this benchmarking module is to compare both implementation in terms of time, for sure, but also to make sure that the output of both implementation are similar. So it's a project under active development and collaboration. So we are more than 60 committers right now. It has been done by more than 10 organizations, and it's right now the 9th version of the project, and we have a lot of industrial also partners that are not directly contributing to the platform, but that can give us a lot of specification or feedbacks or can provide also use cases in the platform. And the idea is also to have also some academic partners that can bring some new features and the top of the research that is done in Europe inside the platform. So we are working a lot with academic partners as well. So we have done a lot of use cases. So I won't go into detail, but if you are interested on, for example, of defect detection and classification, or acoustic monitoring and so on, I can provide you more details about that during the lunch. And I would be very happy to also to see if you have any use case on SDV. That could test the platform. And for us, we have some very key challenges. The first one is to make sure we can support easily heterogeneous architecture and the chiplet architecture. We also want to integrate compilation toolchain because for now we have a source code at the end and let the user do its own compilation. But the idea would be to bring directly inside the platform a compilation toolchain and make optimization also through compilation. For sure, one goal is also to enable to update the model over time, because once it has been deployed, it has to be evolved either by continual learning or federated learning, because we know that also this is also the future of the computing for the mobility, and we want to work on this aspect as well. So you can join us. We have for sure the GitLab on the Eclipse under the Eclipse Foundation. We have a lot of documentation and tutorials with binders so that you can easily test it. We have a wiki for the country to help a new contributor, and we have for sure a chat so that you can engage with the community. So we would be happy to have you on board. So you can follow us, you can follow the project, and you can for sure join this vibrant this vibrant community. So thank you very much for your attention.
Pier.